So let's start this class. Welcome everyone to this lecture. This is lecture number 6 in wave optics, and we are going to deal with polarization. Have you heard about polarization, or you heard the term polarization before?
Sir.
Yes or no? Polarization.
Yes, sir.
Okay. Now, when we talk about polarization, we talk about polarization of EM waves. And do you remember what is EM waves? Do we remember EM waves? Do you remember EM waves?
Yes, sir.
One question will definitely come in your exam based on those EM waves. Now, this EM waves, it consists of electric as well as magnetic fields. Yes or no?
Yes, sir.
Now, light as such is an EM wave. It consists of electric and magnetic fields which is actually perpendicular to each other. Do we remember this?
Yes, sir.
Light propagates as EM waves. These electric and magnetic fields are basically perpendicular to each other. In case of light, name of the chapter is Polarization of Light. In case of light, the magnitude of this electric field is much more as compared to the magnitude of the magnetic field. So, the electric field, the magnitude is much more as compared to the magnetic field. So, in generally, whenever we refer to light, we may refer it as oscillations of electric field, though it consists of oscillations of electric as well as magnetic field. Do we understand this?
Yes, sir.
Even though it consists of both electric and magnetic field, we can refer to light as oscillations of electric field because electric field is much more compared to the magnetic field. Now, there are two terms that you must understand here. The first term is unpolarized light. What do you mean by unpolarized light? What do you mean by unpolarized light? Now, you must know that this electric field and magnetic field and the direction of propagation of these waves, if you remember EM waves, the electric magnetic field and the direction of propagation of wave, what is the relation between the three? How are they oriented?
All are mutually perpendicular.
All are mutually perpendicular. Now, when we are talking about unpolarized light, when we are assuming, we are thinking of light as propagation of electric field. This electric field may propagate in all directions. This electric field may oscillate in all directions which are perpendicular to the direction of propagation. If the electric field is such that it is in any random direction, that direction is definitely perpendicular to the direction of propagation. Such light is known as unpolarized light. So unpolarized light is nothing but a light where electric field may be in any orientation perpendicular to the direction of propagation of the wave. Say for example, your light wave is traveling in the positive x direction. then the YZ plane is perpendicular to this x-axis. Yes or no?
Yes, sir.
If your electric field is in any direction in the YZ plane, it will be perpendicular to the direction of propagation. Yes or no?
Yes, sir.
I can also show it in this way. This dot represents the direction of propagation, and this arrows represent the direction of electric field. Yes, you can call it as a top view or side view. So if electric field is oriented in any random direction which is perpendicular to the direction of propagation of wave, such light is known as unpolarized light. We understand this?
Yes, sir.
Now this unpolarized light, which is right now in the YZ plane, can be resolved into two components, one along the y-axis and one along the z-axis. You can call them as the horizontal and the vertical component. Yes or no?
Yes.
Do we understand this?
Yes, sir.
So you can resolve this you can resolve this electric field oscillation in this direction. Let us say that the direction of propagation is like this. This is the way in which the wave is propagating. Then you can resolve this magnetic field, you can resolve this electric field in the vertical direction. One will be the vertical direction like this, and one will be the direction like this, which is represented by this dot. Do you see this?
Yes,
This
sir.
dot represents along z-axis, and this green represents along y-axis because it is in the YZ plane. Such type of light where electric field can oscillate in any direction perpendicular to the direction of propagation of wave. This is known as unpolarized light. Do we understand this?
Yes.
I'll give you a minute to note this down. Now, since we have understood what do you mean by an unpolarized light, we must be able to understand what will be a polarized light. If we can restrict, as you can see, electric field can be resolved into two components, one vertical and one like this. Yes or no?
Yes.
Now, if we can somehow restrict electric field to only move in one direction along one axis, then the light is known as plain polarized or simply polarized light. Do we understand this?
Yes, sir.
Here, as you can see, this is your original light. You have this as a direction of propagation of wave. Electric field can be resolved into two components. One is up and down vertical, and the other one is this inside direction. Do you see this?
Yes, sir.
Side direction and vertical, inside direction and vertical, inside direction and vertical. So on the left hand side, what we have is unpolarized light. Do we understand this?
Yes, sir.
Now, if you can somehow restrict and allow only oscillation in one plane, one axis, and how do we do it? We do it with devices which are known as polarites. Light can be polarized by transmitting it through certain crystals. These crystals are known as polarites. If you pass it through Polaroid, you can see on the other side what you get. This is the direction of propagation, and now you only have vertical oscillations, and that inside oscillations had been removed. The light on the right hand side is known as the plain polarized light. Do we understand this?
Yes, sir.
Certain things that you need to know. Remember, the plane in which oscillation occurs is known as the plane of oscillation. Do we understand this?
Yes, sir.
The plane perpendicular to the plane of oscillation is known as the plane of polarization. We understand this?
Yes, sir.
One more point you will have to remember. the intensity of the polarized light becomes intensity of unpolarized light divided by 2. You can think it in this way. One oscillation has been removed. One component of oscillation has been removed. So the intensity becomes half. So if I say that the intensity here is I1 for unpolarized light, if I say that intensity here is I1, can you tell me what will be the intensity of the polarized light?
I1 by 2.
The intensity of the polarized light, the intensity of the plane polarized light, if I call this intensity as I naught, this I naught will be equal to I1 by 2. The intensity becomes half. Can you remember this?
Yes.
I'll give you a minute to draw this diagram and note this down. Then the next thing is Polaroid. You don't need to write the definition. Polaroid is nothing but a device which is used to produce plane polarized light. You can see this Polaroid here, yes or no?
Yes.
Now these polarides only allow light oscillation parallel to their transmission axis. This is their transmission axis, TA. Do you see this transmission axis, TA?
Yes.
Do you see these lines, transmission axis? Here the line is horizontal. Do you see this transmission axis?
Yes.
We will only allow, you can just imagine them as a paper which has a slit cut into it. If you cut vertical slits, it will only allow vertical light to pass. If you cut horizontal slits, it will allow only horizontal component. Do you understand this? So you can
Yes.
just you can just think it of as a cardboard which has got some slits. That slits are its transmission axis. The oscillation which are parallel to that slits will pass. The oscillation which are perpendicular to the slits will not pass. Do we understand this?
Yes.
Now, on the left hand side, as you can see, you have unpolarized light. Do we see this unpolarized light?
Yes.
Let us say that intensity of this unpolarized light is I1. Now, it falls on a polarizer. So we have plane polarized light here on this side. Yes or no?
Yes.
The intensity of this plane polarized light I naught will be equal to I1 by 2. Yes or no?
Yes, sir.
Now, sometimes we put a second polaroid on which polarized light falls. This polaroid is known as an analyzer. Do you understand analyzer?
Yes.
Now this analyzer is the axis of polarizer and analyzer are parallel. It will allow all the light to pass through. Yes or no? So the intensity after the analyzer will be here equal to I naught, which will be equal to I1 by 2. Do we see this?
Yes.
The second case, this is unpolarized light. Do we see this? The
Yes.
intensity is I1. Then you have a polarizer. So the light gets plane polarized. What will be the intensity of this light? This is
I1
the
by
question
2.
that is going to come in exam. Yes, I1 by 2. If you put the polarizer such that the axis is perpendicular, the intensity here would be 0. Yes or no?
Yes.
Why it is 0? Because the transmission axis of analyzer is perpendicular. Here it is same because the transmission axis of the polarizer is parallel. Do we understand this?
Yes.
I'll give you a minute to note this down. And we see the next important part, question based on this. If the question comes in polarization, it will be based on this. This law is known as the Malus Law and it is very simple. Basically, without reading the statement, if I tell you, on this side we have unpolarized light, the intensity is I1. Do we understand this?
Yes, sir.
Then you put a polarizer, which is the first polaroid. The intensity becomes I naught. This I naught will be equal to how much?
I1 by 2.
I1 by 2. Now I have the analyzer Now I have the analyzer, and you can see their transmission axes are inclined at an angle of theta. Do we see this?
Yes.
Now the intensity of the Polaroid, the light after analyzer, if I call it as I, that I is given by I naught. What is I naught? I naught is the intensity of the polarized light. Do you understand this?
Yes.
Cos square theta. That is what is known as the Malus law. The intensity of the light after the analyzer is I naught cos square theta, where theta is the angle between the plane or transmission axis of the polarizer and the analyzer. Do we understand this?
Yes.
I'll give you a minute to if I talk about the amplitude of the light after the analyzer, what will be the relation between amplitude? If I call the amplitude of this light as A naught, if I call the amplitude of this light as A1, can you tell me the value of A naught in terms of A1? A naught will be equal to A1 by root 2, and A will be equal to A naught into cos theta. Do we understand how I've got this?
Yes.
How I've got this?
Intensity is
Intensity is directly proportional to
A square.
intensity is directly proportional to A square. I'll give you a minute to note this down. The next heading is known as Brewster's Law. And this comes under the heading of polarization by reflection. Polarization by reflection of light. Now what happens, this was discovered by Brewster, and therefore it is known as Brewster law. Just making you understand the definition is not good. I'll just make you understand. Here what you see is an unpolarized light falling on a boundary between two mediums. Do you understand this?
Yes.
At different angles of incidence, you will have one light which is refracted, and you will have one light which is reflected. Yes or no? Some part of light will be refracted, some part of the light will be reflected. Do you understand this?
Yes.
He found out that at a particular angle of incidence, which is known as Brewster angle, at a particular angle of incidence, which is known as the Brewster angle, for a particular angle of incidence, which is known as a Brewster angle, the reflected light is completely polarized at a certain angle of incidence. That angle of incidence is known as the angle of polarization or Brewster angle. And he gave this law by a simple analysis that mu, the refractive index of that material, mu, would be equal to tan of the Brewster angle. This law is known as Brewster's law. Do we understand this?
Yes.
That means if the angle of incidence is actually exactly equal to the Brewster angle, the light which is reflected will be perfectly plane polarized, whereas the refracted light will always be partly polarized. The refracted ray is not completely polarized, it is partly polarized. Do we understand this?
Yes.
Also, one more thing you must understand, that in this case, when the reflected ray is completely polarized, when the angle of incidence is Brewster angle, and it's a very important result, both the reflected and the refracted ray are perpendicular to each other. Do we understand this?
Yes.
If the angle of incidence is such that the reflected and the refracted light are at 90 degrees, then the reflected light will be perfectly polarized. That angle of incidence is known as Brewster angle, and tan of that Brewster angle is equal to mu. This is known as Brewster law. Do you understand this?
Yes.
If the angle of incidence is less than or equal or less than or more than Brewster angle, the light will not be perfectly polarized. The reflected and the refracted light will remain partly polarized. Do we understand this?
Yes, sir.
So, what all things you need to remember about Brewster's law? Mu will be equal to tan of Brewster angle. Do we remember this?
Yes.
Second point, reflected and the refracted ray will be at 90 degrees. Do we understand this?
Yes, sir.
These are the two things that you must remember. I'll give you a minute to note this down. And before moving on to question, let us just note this Doppler effect in light. I've seen some questions come from this part as well. You just need to remember what is Doppler effect. We have seen Doppler effect in sound, yes or no? When the source or the observer is moving, then the apparent frequency is not the same as the real frequency. That shift is known as the Doppler shift, yes or no?
Yes.
What you need to remember is this formula is here. When the source of light moves towards the stationary observer, then we call it as the red shift. The apparent frequency will be less than the apparent wavelength will be less than the original wavelength, and the apparent frequency will be more than the actual frequency. Do we understand this? V is the speed of the source and C is the speed of light. This is known as the red shift. You will see the star appearing red. Do we understand this?
Yes.
This is a very important formula. What is the change in frequency? What is the change in wavelength? You can subtract both. You will find out the change in wavelength is lambda V by C. On the other hand, when it is moving away, frequency will be less, wavelength will be known. That will be known as violet shift. The shift in the wavelength is the same, whether it is a red shift or a violet shift. Do we understand this? Just need to note down the formula. If you understand just one formula, rest of the formula are just a replicate of this. Do we understand this?
Yes.
I'll give you a minute to note this down. Then we can note down this relation between Doppler shift and the time period of rotation. The relation is like this. You may just encounter a question where they ask you what is how they are related to each other. So just note it down. Do we understand this?
Yes.
Note it down, please. I think you just need to make a correction in the notes. When the wavelength decreases, it would be the violet shift, so it is just written in the reverse order. When the wavelength increases, it would be the red shift. Red has got more wavelength than violet, so it's the opposite. So when the source is moving towards the observer, frequency increases, wavelength decreases, violet shift. Frequency decreases, wavelength increases, red shift. Will you remember this? I
Yes.
think the in the notes it was given opposite. I have corrected it as well. And let us now move on to some questions. And this is a question that was there in your JEE of 2022. Remember, questions are pretty simple if you know the concept. They are pretty simple. So without saying anything, I will present you this question and I'll give you 2 minutes to solve this. So, what is the shift in wavelength? The shift in wavelength delta lambda is equal to V by C multiplied by the original wavelength lambda. Yes or no?
Yes.
It is 286 kilometers per second. So, 286 into 10 raised to the power 3 divided by speed of light is 3 into 10 raised to the power 8 multiplied by 630 into 10 raised to the power minus 9 nanometers. I think the answer that is going to come is going to come approximately 6 into 10 raised to the power minus 10. So the value of x is going to be 6. Do you understand?
Yes.
See, the questions that are going to come is pretty simple and pretty straightforward. If you can just keep your emotions in control, you should be able to solve the question. Again, this is a question taken from your 2022 JEE, and the question goes like this: an unpolarized beam is incident on a polarizer, and the intensity of light emerging is 100 lumens. That is the SI unit of intensity. Now, if the analyzer, this is the intensity from the analyzer. Now, if the analyzer is rotated by 30 degree in the clockwise sense, what will be the intensity of the light which is emerging? So previously it was like this, now it is rotated by an angle of 30 degrees. Do you understand the question?
Yes.
2 minutes you have. So we understand the intensity after the analyzer, yes or no?
Yes.
Everyone understand this or shall I do it? The intensity after the analyzer will be I naught cos square theta. When they were parallel, it was the same. When it changes, it becomes I naught, which is 100 multiplied by cos square of 30 degrees. So this is 75. Do we understand this?
Yes, sir.
Everyone understand this? These are the type of questions that are going to come in your exam. This is again a question from 2022 JEE Main. You can see they put similar questions. If you understand their concept, you should be able to do good. A source of light placed in front of a screen. The intensity of light is I. Two polarized P1 and P2 are so placed in between the source of light, so the intensity on the screen is I by 2. In first case, it is I by 2. Polarized P2 should be rotated by how much degree so that the intensity becomes 3I by 8. And yes, my dear friends, the answer is definitely 30 degree. Do you understand the how it's going to happen? Yes or no?
Yes, sir.
So how are they placed previously? Previously, they must be placed in such a way that they are parallel to each other. Yes or no? P1 and P2 will be parallel. Then only you will have I naught by 2 coming on the other side. In second case, P1 is just like this. P2 should be rotated cos square 30. So 3I by 8 should be equal to I, which is the intensity. The original light intensity is I, so I write it I know I by 2 cos square theta. Do we understand this?
Yes.
Normally, the answer in this case would be the 30 or 60 or 90, the angle or 45 or 37 or 53. Questions are framed in that way, beta. Do we understand this, everyone?
Yes.
Okay, now let me put this question for you. Similar question, and from this question, all the other questions were made. So this is the question. Two polarites are oriented with their planes perpendicular to the incident light and transmission axis, making an angle of 30 degrees with each other. What fraction of incident light, what fraction of the unpolarized light is transmitted? I'll give you a minute to give me the answer. 3 by 8 is correct. The original intensity, if I say I1, then the intensity after the first polarizer will be I1 by 2. Yes or no?
Yes.
the intensity of the analyzer will be I1 by 2 cos square 30 degrees. So it will be equal to I1 by 8. Yes or no?
3I1 by
3I1 by 8. That is the intensity that is passing. What fraction of the light is passing? It is very simple that the fraction of light that is going to pass will be 3 by 8. Yes or no? Anyone understands this?
yes, sir.
I saw a question in your this attempt, and I'm just looking to get that question. I have all the papers when I need to search all the papers to find out that question. If you are lucky enough, you will get that question. Let's see, I'm trying to find it out. I saw a couple of questions from this polarization. Can't locate them now. But have you understood? The only thing that is going to come is questions on questions of this type where they will give you one Polaroid, one polarizer, one analyzer, and then they will ask you how much light is passing through. And yes, do we understand questions like this?
Yes, sir.
Everyone understands them? Just looking if I can get that question. And oh, I got it. You are in good luck. So this is the last question, and this is from the JEE attempt of 2013, 2013, 2023. 2023. This is February 1, shift 1. I don't know how many of you gave this question. So you can look at the question and give me the answer. Now, unpolarized light of intensity I naught is falling on a polarizer system in which the successive transmission axes are at 45 degrees. Find the number of polarizer if the final intensity is I naught by 64. So basically, after the polarizer, there is not one analyzer. There are a number of analyzers. Do we understand this?
Yes, sir.
You have to find the number of analyzers. They are calling it polarizer. So, how many polarizers are there? You will have first polarizer, then you will have second, third, fourth, fifth, sixth, seventh, and so on. How many? How many polarizers are there in all?
5I.
6. After the first polarizer, the intensity will become I naught by 2. Yes or no?
Yes,
After the second polarizer, intensity will become I naught by 2 cos square 45. So that becomes I naught by 4. That becomes I naught by 2 square. Yes or no?
yes,
After the third one, how much will be it? How now I naught by 2 cube. Yes or no?
yes.
So after how much polarizer it will become I naught by 64?
2 power 6.
2 to the power 6. Therefore, the number of polarizers have to be 6. Do we understand this? Total number of polarizers have to be 6. Do we understand this?
Yes, sir.
That brings us to an end of this class, and that brings us to an end of this chapter as well. In the next class, we might be going in the revision mode, and we might start with the chapter errors. And I will show you some question on errors, and we'll try to tackle them. Okay. So have you understood what we have done in today's class?
Yes, sir.
Okay, then I'll take your leave, and we'll meet in the next class. Take care. God bless all of you. Bye bye.
Thank you, sir.